Hi, I'm Dave, and I'm making my gear.
Bye. We are at part 6 of the ESP32 sampler. Past couple weeks have been really intense with the coding, and this week is going to be not so intense. It's going to be pretty straightforward. We need our record button hooked up, and we need a LED indicating to us that we are recording. And then we have a sample storage LED, and then we're going to have our loop set button. And for those who don't know what the loop set button is normally when you hit a key, it plays the sample once while the key is held down. Instead, with this function, what we're going to be able to do is hold down the button. The sample will loop over and over and over again while we're holding the button. And that's it. So yeah, let's hook up some LEDs to the ESP32. Let's hook up our push buttons and get down to business. For the record button and the loop set button, I am using our usual tactile push button. And we've got our LEDs. We've got our green LED and our red LED, and we need a couple current limiting resistors for that, which are 330 ohm resistors. We are using a couple 10K resistors in our circuit for the buttons because the pins don't have pull-up resistors. Okay, so it's kind of hard to see everything wired properly on this rat's nest of a breadboard. So let's just jump over to KiCad and I'll show you how I have these things wired up. It's super straightforward. Let's do that real quick. This is how I have things wired on the breadboard. For the record button, we are going from GPIO 34 to one side of our push button, and the other side of our push button is connected to ground. Now on that line, we have a 10K resistor connected directly to 3.3 volts. This is going to pull this GPIO pin high, so when the button is pressed, the signal gets shorted to ground and we know that we are recording, okay? The same circuit is used for the loop set button, except this time we are connected to GPIO 35. Then for our record LED, we are hooked up to GPIO 15, and we go into the anode of our red LED. The cathode connects to a 330 ohm resistor. The other side of the resistor is connected to ground. The same thing is done with our green status LED. The only difference is that it's a green LED, and we are connected to GPIO 14. Now let's hop into Arduino and check out the code. So this code walkthrough, I'm going to focus specifically on additions and the slight modifications that I had to make to the code to get this stuff to work. To start off, we've got two new definitions for LED recording, which is assigned to GPIO 15, and LED stored, which is assigned to GPIO 14. And going down, we've got two more definitions. We've got the record button assigned to pin 34, and the loop mode button or loop set button assigned to pin 35. And this new logic stuff is used to determine whether the loop mode has actually been pressed, and also some debounce. So nothing misfires. Everything else is exactly the same. And then we're into our setup. And right here, the LEDs are configured as outputs. LED recording and LED stored pins are also set to output. They're initialized low, so they are off at startup, okay? So then we have the record and loop buttons assigned as inputs. We're using external pull-up resistors in this circuit, so these are just set as input. Next, let's go to our main loop. Okay, so the first big change is we've shifted our record audio function from the setup to the main loop. So the first thing we do is we check if the record button is pressed, active low. We debounce it to avoid false triggers. Then we call record audio and print our summary. Then we want to read the loop toggle. We read our loop toggle button, looking for a button press event, the transition from high to low, right? And toggle the loop mode accordingly and print in the serial monitor the new state, whatever we've pressed. That's just for debugging. Okay, then everything else is pretty much the same. And then let's go down. So the recording audio. Okay, so first thing we do is we light up the recording LED so that we know it's active. And then the sampling part of it is exactly the same. So we sample the mic input at precise intervals to maintain the correct sampling frequency. The analog reading is 12 bits, so we shift it down to 8 bits by discarding the lower 4 bits. And all the samples go into the raw audio data buffer, right? Well, now the difference is when we're finished, the recording LED gets turned off and the LED stored light gets turned on so that we know that the sample is ready to be played. Okay, so now let's go to handle audio playback. There's a little bit more to it this time. And the main difference here is this little section right here. And what this section is doing, it's actually controlling the loop mode portion. So if loop mode is engaged, what happens is if we reach the end of the sample, we either loop back or stop playback depending on whether loop mode is engaged or not. All right, let's get the sampler hooked up to our guitar amp and test it out. All right, so let's do a quick demo of everything working here. I've got my little mini guitar amp hooked up. The unit is powered on, and as you can see, both of our LEDs are low, which means nothing is recording and nothing has been recorded to memory. So let's press the record button. We'll record something really quick and see how that works, okay? So let's do it. I don't know if you can see that on the screen, but the record LED lit up for 1.4 seconds while we were recording, and now our green LED is lit, showing that we have something stored into memory. Now, I'm going to play the keypad like normal, and you can hear the sample. Okay, cool. Now let's try the loop set button. So I'm going to press the loop set button, and we should get our looping playback. Okay, we're done. We got our buttons, we got our LEDs, thumbs up. Very happy with that. You know, a little bit easier this week. Definitely needed a bit of a breather. It's been intense, you know, with that coding. Next week, we're going to jump into a better microphone. It's time to get that better microphone sorted out. So stay tuned for that. Hope you enjoyed the video. If you like what I'm doing here, please subscribe to the channel. For those who have subscribed, I salute you. And thanks for watching. And I'll see you next time.